All right, so example 3, we're being asked to use geometry to evaluate the following definite integrals. So what this is really about is getting us to read what question this is asking me. All right, so the question is, what is the signed area under the curve g of x bound by these vertical lines x is 0 and x is 2. All right, so they've given us the curve g right here, and we're looking as x goes from 0 to 2. So as x goes from 0 to 2, the area under the curve g, which we really mean between the curve and the x-axis, is this area right here. I'm shading it blue just because it is positive. We are above the x-axis there. All right, so notice that that's a right triangle. The base is got length 2, and the height is length 4. The area of this guy, remember it's 1/2 base times height, 1/2 2 times 4, which is just 4. That's your answer. Done. Okay, so what we're practicing is reading this as an area question and then seeing that area on our graph. Okay, so now in the next one, we're looking for the area under G again. We want to know what is the signed area under this curve bound by these vertical lines. And now their x equals 2 and x equals 6. All right, so here I'm going from 2, 4, 5, 6, right here, from here to here. And because I am below the x-axis, those Riemann sums, right, the heights all here are negative, times your little base, your little change in x. Remember that little change in x is b minus a all over n. As long as b is bigger than a, right, which we typically will do, that number is positive, and a negative times a positive is a negative. I'm below the x-axis. This is a negative area. All right, so notice that this is, it's going to be negative because we're below the x-axis. This is half the area of a circle with a radius being 2. Right, so it's minus a half. Area of a circle is pi r squared. We've got minus a half times pi times 2 squared, which will be minus 2 pi. And you could say units squared if you wanted. All right, and now on the last one, we are asked to find the area under the curve G, meaning between G and the x-axis, as x goes from 0 to 7. And again, these are all signed. So this is where you're starting, and this is where you're stopping. X equals 0, and x equals 7. So notice, so we're going from here, from 0 to 7. We've actually already found some of the work here. We went and found this area. We found this signed area here. And this is all that's left to be done. Right? So the area of that triangle was 4. The area of that circle below the x-axis was minus 2 pi. And then what's the area of that? Base is 1, height is 1. 1/2, 1 times 1 is a half. You can see that we've got half of a square right there. So here's our answer. 4 plus a minus 2 pi plus 1/2. All right? And I'm just going to leave it like that. Okay. So what we've been practicing again is reading this as a signed area. And then we've been using geometry, once we can visualize that area, using geometry to say what the answer of this definite integral is. We're going to want to be able to find more complicated areas, and the beautiful way that we're going to be able to answer this question is thankfully not with this intense limit definition, but with something called the fundamental theorem of calculus.